Okay, so now we're going to look at the postulates and axioms on the review. So postulates, remember, something that we just assume to be true. So we're going to look at the postulates and axioms. We don't have any special guest stars for this particular one. I think I've run out of characters. So actually, we could have a Ninja Turtle. But that doesn't matter. So anyway, postulates and axioms. Any blank blank points determine a plane, okay? Any three non-collinear points determine a plane. Now we talked about earlier, if I drew three collinear points, collinear meaning they're on the same line, that's still a segment or a line. That's not a plane. In order to establish a plane, I've got to have non-collinear points. These points are coplanar. They are in the same plane because they are collinear, therefore they are coplanar. But in order to establish a plane, I have to have three non-collinear points. So if I draw another point up here, now I can draw my plane. Okay? Ignoring this point right here, I've got three non-collinear points. They're making my TP looking thing. All right? Any three non-collinear points. So when you name a plane, name it with three letters, and it has to be three non-collinear points. Okay? The next one says any blank points determine a line. Any 2 points determine a line. Doesn't matter where I draw the 2 points, there is exactly one line that contains those points. Anywhere I draw those points. I could draw a point here and a point here. There's another line. Anywhere I draw 2 points, I can connect those 2 points with a line. I can connect those 2 points if I wanted to. Okay? There's all kinds of points. Here's another point. I can connect these 2 points. Any 2 points can determine a line. Okay? All right, so let's look at midpoint and distance. Midpoint is the actual middle point. That's why when we do segment addition postulate, we say between, because the midpoint is actually the middle point. Now, for midpoint, we do have a formula for midpoint. Now, there's midpoint on the number line and there's midpoint on the coordinate plane. This is going to be midpoint on the coordinate plane. The formula for midpoint is the average of the 2 x coordinates, which is to add them together and divide by 2, and the average of the 2 y coordinates. This will give you an x coordinate for the midpoint and a y coordinate for the midpoint. So that's how we do midpoint. So basically, I'm going to set up this formula. And what I'm going to do with this formula is I'm going to plug in my x's and y's into the formula to find the midpoint. Now, I don't like formulas. I show them to you because I have to, and because I can't draw straight lines, because it is almost midnight. Yay! No sleep for me again. So I've got these two are actually averages. This is the average of the x's, and this is the average of the y's. If you make a 90 and you make 100, what's your average? 95. How did you get that? You added them and divided by 2, right? Because there's 2 grades, you divide by 2. So to take the averages, let's look at our 2 points. Now I'm going to set this up formula-wise. I always like to write the formula out and then plug in my values. So what are my 2 x coordinates? -2 and 4. So those are my 2 x values. What are my 2 y values? Well, you know that this is y1 and that's y2. So 4 and 7. And those are x1. Let me put these in here. That's x1 and that's x2. So all I'm doing is adding the coordinates and dividing by 2. I'm just taking the average. Just taking the average. That's all it is. So -2 plus 4 gives me 2, and 2 divided by 2 gives me 1. 4 plus 7 is 11, and 11 divided by 2 is 5.5. So that is where my midpoint is. If I were to graph these 2 guys on the coordinate plane, and I could possibly do that over here, but I'm probably going to run out of room. I have -2, +4. So that's where A is located. And then I've got 4, 7 for B. 1, 2, 3, 4. 1, 2, 3, 4, 6, 7. B is up here at 4, 7. The midpoint is going to be exactly between these two guys on this line. So I got 1, 5.5. So if I go over 1 and I go up 5.5, that actually looks pretty good, right? That looks like it's right between A and B. So that's how we determine a midpoint. That's what a midpoint is. It's equidistant from each endpoint. Equidistant from each endpoint. What a midpoint looks like on a number line, if I were to actually draw a single line, a segment, with a midpoint in the middle, do you remember how I showed you mark these congruent? Those are the congruent markings. AM is congruent to MB because M is exactly the same distance from A as it is from B. Okay? Alright, so let's look at the next one. The next one says if one endpoint of a segment is at H and the midpoint is at M, what are the coordinates of the other endpoint? So what we're going to do for this one, draw the picture. Always draw the picture. Even if your picture is really scary, draw the picture. So I've got H, and then the midpoint, and then T. So H is here, and that's located at -4, 3. Now I'm just going to put this on the segment instead of writing it on the graph, just for simplified purposes here, because we haven't quite gotten into all that yet. There's your midpoint. And T, well, we don't know where T is. We know one endpoint and we know the midpoint, but we need to find the other endpoint. So remember, I'm going to do the stack. I told you about stacking it. H is one endpoint. That's -4, 3. My midpoint M is at -1, -2. And T, I don't know. T is what I'm looking for. So let's use some properties that we have that we know how to use. Okay, first of all, I want to know how far apart this x-coordinate and this x-coordinate are. How far apart are -4 and 1? Well, do you remember we do absolute value? We do the difference. The absolute value of the difference tells you, some of you could count, but I'm going to make you do it this way. So I'm going to go from -4 to -1. -4 minus a negative changes to plus a positive. So -4 plus 1, which would be -3, and the absolute value is 3. So to get from H to M, I added 3 because I got bigger. Well, if M is right in the middle, shouldn't M be the same distance from H as it is from T? So if M is 3 units away from H, M also has to be 3 units away from T. So I'm going to add 3 more, and that puts me at 2. So 2 is the x-coordinate. Now, let's look at the y-coordinates. I went from 3 to -2. Okay? From 3 to -2. Sorry, I was hearing something in the background. So, I'm going to take my coordinates, and I'm going to go 3 minus -2. Minus a negative becomes positive, which is 5. So to get from -2, from 3 to -2, I did 5. Plus 5 or minus 5? I got smaller, minus 5. So to get to the next one, I'm going to minus 5 there as well. So -2 minus 5 more puts me at -7. So this is where your endpoint is. You have to find out how far away each of these coordinates are from each other. Okay? So let's look at finding the length. First of all, distance is the same thing as length. Okay? Distance is the same as length. All right, so let's move on down here to number 4. Number 4 gives us a number line. And this is practice with the absolute value. Using absolute value, find the length, okay? So let's look at A. A is TM. I want to know the length of TM. So I'm going to come up here. TM is going to equal the absolute value of the difference between T and M. Well, let's look at T and M. Where is T located? T is at -9. Where's M located? At 1. So TM is going to be the absolute value of -9 minus 1, which is -10, which is 10. So TM is 10. If you want to write out the exact, if you want to put it all here under here, you can. -10. So the distance from T to M is 10. That's all you had to do. Now let's do BG. Okay? BG. B is at -2. G is at -10. So I'm going to take the absolute value of the difference. -10 minus -2. Minus a negative changes to plus a positive, so -10 plus 2 is -8. But distance is positive, so the distance from B to G is 8. And that's how we do number line distance.